Okay, what we're going to do here is we're going to demonstrate the MIDAS Meter handset on our PDA device. This is a valve leak detection tool. To demonstrate how it works, we've built this little manifold system. You can hear a little compressor making noise there in the background, so we're generating a differential pressure, air coming in at the top, connected pipework to 5 quarter-ton ball valves. Just to simulate a leak, we've opened one of the valves very slightly. At the moment you don't know which valve that is. Conjoined pipework leads out to our flow meter on the bottom here, and you can see that we do have a little bit of leakage coming through. And what we're going to do is we're going to identify, using the MIDAS meter, level 1 operation is troubleshooting which valve is leaking. So first thing we do with the MIDAS meter, hit the big yellow button, switch it on. You'll see it says on, and then it'll jump to a 2-digit number, B, in this case 75, that means it's got 3/4 of a charge in the battery, 75%. Then we drop to our background reading, which is normally 21 plus or minus 1 decibel. So you can see it's fluctuating between 20 and 21 decibels. So that's a normal background reading, tells us the sensor's good. To survey each of our valves, we place the acoustic emission sensor in the front end here on the valve, and we wait for something like 6 to 10 seconds. You'll see we're using a little bit of silicon coupling. That's just to make sure there's no air gap between the valve and the sensor. So I place it on the first valve here, and what you'll see is we have a decibel reading here of 29 decibels, jumped up to 30 there. So what that's telling us is that there's some noise in the system, but we're not really sure yet if that's the leaking valve. So the way to identify the leaking valve is to look for the peak signal. So the valve that's leaking will have a much higher number than the other 4 valves. So again, you'll see this one sitting at almost identical. We're at 31, 32 decibels here. Pretty stable. So we have 5 valves in the system. This valve here is significantly higher at 53 decibels, 54, so that's now a suspect valve, but we want to do all 5 just to make sure. So here we are in the valve next to it, and we're back down at 35 decibels, 36. We're pretty stable at 35, 36. And our last valve, .33 decibels. So what that's indicating to me is that I didn't know which valve was leaking, so it would cause me to want to repair all 5 valves, because in the absence of that evidence you're forced to do 5 repairs, use 5 repair kits. It takes 5 times as long and it comes at 5 times the cost. What we've done now is we've identified down to 1 valve. And just to prove the MIDAS meter is correct, what we'll do is we'll have a look in behind at the hand levers, and you'll see which one has been opened very slightly. And if you look very subtly, it is of course number 3. So we can see that literally with just a few seconds worth of surveying, it's a completely non-invasive survey, and we got the correct answer. So the next thing I want to do is I want to show you, we can also use this as a maintenance verification tool. So if I simulate the maintenance program by closing that valve, you can see that our leak rate has disappeared. There's no longer any leak coming through the valves. So I'm just going to demonstrate what happens with the decibels. I've come back onto the valve that gave me the 52 decibel reading, and you can see we're back down at our background reading. So we're now using the MIDAS meter to verify that the maintenance program has been effective in removing that leak from that valve. So that's level 1 operation, that's troubleshooting. Of course, now that we know that there's only 1 valve leaking, we're not going to repair all 5, we're just going to repair the leaking valve. So this allows us, even just with simple use of the handset, to move towards value-based maintenance. We ignore the other 4 valves because they're all working fine, and we only do maintenance on this valve here. That's alternative to the original discussion we had, where if you don't know which valve's leaking, you have to use those 5 spare skids. So what I've just demonstrated there is 80% cost savings available from your current maintenance program. Targeted maintenance on the problem valves will remove most of the costs that you incur in your maintenance program. Now, the leak that we had there was a tiny leak. You saw it was probably sitting just above 5 litres per minute of air. You're not going to stop a process for 5 litres per minute of leakage. If it was significantly higher, then you might make an interruption in your process. Bear in mind that typical test techniques like pressure build-up or pressure area tests are very expensive. One of my customers said to me a few weeks ago, it takes $2.5 million on an offshore oil rig to run a pressure build-up test on an emergency shutdown valve. So nobody wants to do that. So using this device, just exactly as I've used it there, we can do exactly the same test technique as pressure build-up, but what we're going to do this time is we're not just going to look at the readings that are available on the handset here. What we're going to do is we're going to do a complete survey so that we can quantify the leak rate coming through that valve. And the way we do that is we push the button from there and it sends that decibel reading into the valve details on our PDA device here. So you can see we've set the valve up. It was valve number 3, TV003, and we go into tests, and what we want to do is a new test today. So I'm going to click on new. It asks me if I've got the correct date, which we do have. We're now in the area where we want to populate our decibel readings so that we can do that conversion into a leak rate. So the first thing I need to do is make communication with my handset. So every single handset has a unique reference number, and that tells me which handset I'm using. What we want to do is make sure that we're not sending our results to someone else's PDA. So here we go, we've selected the handset, it's making the Bluetooth connection, and then we'll come to our live reading screen. So the first thing you can see on the screen is that my reading here is identical to my reading on my LCD screen there. So to make this nice and simple, we've set up a pre-planned route. So if I just click on route, it automatically tells me how to run the test. So I'm going to click start. It tells me where to take the reading and how many readings to take. So the first one is a background reading. So in this case, background reading, we're just taking in air. So I press the send button. We've now got a time and a date stamp with 20 decibels, and we want to move to the next position. Doing that, we press and hold the H button. You'll hear a different noise. It's now asking me to take a reading at upstream far. So we're going to take 5 key readings. The readings will be upstream far, upstream near, on the valve body, downstream near, and downstream far. Taking these readings will allow me to quantify the leak rate. So just to make sure I'm getting a good signal transfer, I'm also going to use some silicone grease on these new reading positions. So I'll just put that on the positions first to speed up my survey. And now I'm going to come back and I'm going to take my readings. So it's asking for upstream far and 1 single reading. So I'm going to come on here. I want to be on for about 6 to 10 seconds to see it stabilise. Let's just make it leak again. So I'm bringing back my valve leak. You can see we've got a little bit of leakage coming through this time. So let's go and take our 5 key readings. So again, you'll see the numbers are identical on both screens. We've stabilised around about 28 decibels and I've sent that through. We've recorded the 28 decibels here. Okay, and I press hold again to move to the next position for 4 seconds. It's now asking for upstream near. So here's my upstream near reading. Again, you should be on long enough just to see that number stabilise. We are seeing a little bit of fluctuation in the numbers here because the compressor can't keep up with the leak rate. Hold again. Okay, now it wants the valve body reading. Because this is a small valve, it's just asking for one reading. If it was a large valve, it would want more than one reading. So let's just take our body reading now. Okay, 51 decibels there. Okay, 2 more readings to take. Downstream near, again a single reading. Downstream near. And our final reading will be downstream far. Again, just a single reading at that position. You can see most of the decibels that we saw on the valve body are already disappearing. 26 decibels there. So one more press of the hold button, you'll hear a different sound. That tells me my route is complete. I need to do one more thing, and that is to add in the pressures. So on the upstream side, we have approximately, looking at our pressure gauge here, we're fluctuating it in and around 3.5 bars with the compressor kicking on and off. So I'm going to use 3.5 bar for my upstream reading, which is there. We're coming out to atmosphere, so I'm going to leave that as 0, and we can change our units here between bar and PSI if we need to. So that's me completed my survey. You can now see we have an analyze button, and this is what's going to take me to my leak rate calculation. So if I click analyze there, it immediately does the conversion. So what we said was we could live with 5 litres per minute of leakage. What we've actually measured is 9.86, so almost 2 times the allowable. So we have a red traffic light. That would indicate to your maintenance team that maintenance is required on that valve. Good.